Human beings have always felt the need to explore new places. Since their origins, they have spread progressively until they have taken over the whole planet.
We are voyagers, we are explorers, and we are colonizers. We've done this everywhere.
Now, our next frontier could be the moon. Climate change, overpopulation, or the possible impact of a big asteroid could force us to leave the Earth and expand to other places in the solar system. Beyond the Earth, there are a large number of resources that might let us to grow as a civilization.
For now, a tiny fraction of the asteroid belt is more than enough to supply a virtually unlimited material for space industrialization and space colonization.
Human beings know no boundaries. The recent discovery of water on the moon has led to the development of new plans to finally return there. All over the world, several private companies and public institutions are working to make it soon a reality.
In the coming years, there will be several activities on the surface of the moon.
Building a home on the moon will force us to face new challenges such as low gravity, the lack of atmosphere, lethal radiation, and extreme temperatures.
The temperature difference is so great that it actually triggers seismic activity.
We will have to build safe habitats, to design efficient transport, to obtain energy, and to produce food and other needs to supply the future colony. Undoubtedly, the construction of a lunar base would be one of the greatest technological challenges humankind has ever faced. Engineers and scientists are working to begin a new era of manned space exploration. Our generation might be remembered as the first one that managed to settle a lunar colony. The moon. The brightest and largest object in the night sky. It is the closest large body to Earth in the solar system, at a distance of only 239,000 miles. The moon is the only celestial body on which humans have set foot. Exploration of the lunar surface by spacecraft began in 1959 with the Soviet Union's Luna program. Luna 1 failed to land on the moon. However, Luna 2 did succeed in landing, becoming the first artificial object ever on an extraterrestrial body. Several unmanned lunar probes followed those pioneering missions during the following 10 years. Just a few years later, in 1969, a great milestone was reached. The Apollo 11 lunar module landed 2 astronauts on the moon. For the first time ever, a human being walked on a celestial body besides Earth.
That's one small step for man, one giant leap for mankind.
Since then, 12 others stepped on the moon in the different Apollo missions. The last one, Apollo 17, was launched in 1972. It marked the end of the Apollo lunar mission. After that, for several decades, the moon as a priority target disappeared from the programs of space agencies, and human beings didn't walk on the moon again. Given the fact that it's so close to Earth, and considering our interest in exploring space, why didn't we go back to the moon?
This was in a totally different time than we are today. This was in the time of race in space. It was about prestige. It was about showing the power and the possibilities a nation has.
Nevertheless, in 2009, something happened that changed everything and encouraged space agencies and private companies to start once again to develop manned missions to the moon after so many decades of lack of interest. That year, the Indian Space Research Organization's Chandrayaan-1 probe made a surprising discovery that put the moon in the spotlight. It discovered the widespread presence of water molecules in the lunar soil, overturning theories that had stood for 40 years.
The Chandrayaan-1 mission was a very special turning point in the exploration of the moon.
Some of the payloads on that mission conclusively verified the presence of water ice. Just 2 months after that, in November 2009, NASA reconfirmed water on the moon with its Lunar Crater Observation and Sensing Satellite Space Probe, which detected large quantities of water ice.
We are talking about scooping something, melting it, and water. You know, that makes a big difference to get water that you can drink, that you can live by, water. The Indian mission clearly showed a sign of water, not as composites of minerals or anything like that, just water.
In March 2010, it was reported that the Minisar on board Chandrayaan-1 had discovered more than 40 permanently darkened craters near the moon's north pole that are speculated to contain an estimated 600 million metric tons of water ice.
This was quite revealing because for about 30 or 40 years, there's been debate. There's been a growing debate about, is there water on our moon?
If future research finds large enough quantities of water ice, it could be turned into liquid water for drinking and plant irrigation. It could also be split into hydrogen and oxygen with the energy provided by solar panels or a nuclear generator. The hydrogen might be used as rocket propellant and the oxygen for breathing.
NASA now, after the Chandrayaan-1 mission, they've gained the support to put together a mission to go to the surface of the moon. They're going to put a rover on the moon that has the ability to scoop the material and examine it. And I think that will convince everybody that there's a lot of water on the moon.
Nowadays, thanks to this discovery, human beings are thinking of going back to the moon again after many years. In fact, the moon might become our first space colony in the near future. We have the technology and the know-how we need to do it. But what drives human beings to consider settling a colony beyond the Earth? There are several reasons that lead us to suppose that, sooner rather than later, human beings will go beyond the boundaries of the Earth to settle somewhere in the solar system.
We've done this everywhere on this planet. We've colonized every place that we could possibly colonize on this planet. So it's a kind of genetic thing.
The rise in population is causing an increasing need for resources. The Earth is becoming too small for so many inhabitants.
Population on Earth has become a controversial problem now for a long time, starting with the limits to growth movement.
We need to find more raw materials to support our whole population and so that civilization could keep on progressing. Those resources are out there.
There's enough material in the asteroid belt to build beautiful space colonies with a total land area 1,000 times that, the surface of the Earth. a habitable volume capable of sustaining a human population of 1 trillion people, which gives us the promise of humanity expanding, growing, and thriving for at least another 1,000 years.
On the other hand, there are hazards now that lead us to think that we may have to leave the Earth someday. Climate change has become one of the greatest dangers humanity has ever faced, and could lead civilization as we know it to its destruction if we don't stop it in time.
We should do exploration because it's in our genes to be curious, but at the same time we should save our planet as much as we can. And through exploration we can learn about our planet.
Undoubtedly, there is in human beings an internal impulse that makes them explore new frontiers. Now, our next step could be the Moon. The discovery of water there, an indispensable element for life, was the key factor that lets us consider our satellite as a possible future home. However, the Moon is not a hospitable place for human beings. So the challenges that we all have to face to settle a colony there are very great. Despite its proximity, the Moon has characteristics that make it a very different place from our planet. First of all, its diurnal period is very different from Earth's.
It depends where you are on the Moon, the length of day. If you go to the poles, your day can last most of the year because you're in almost permanent illumination. If you go down to the equator, then you get about 2 weeks. So you know that you've got about 2 weeks of day and then you've got about 2 weeks of night. So it would be a completely different way of living, and you'd probably have to artificially create day and night.
Its gravity is also different from Earth's. While we have a gravity of 1g here, on the Moon, it's just 1/6, 6 times less than on Earth. As of today, we don't yet know exactly how this lower gravity could affect human health in the long term. We know that exposure to weightlessness over month-long periods cause deterioration of physiological systems, such as loss of bone and muscle mass and a depressed immune system. Similar effects could occur in a low-gravity environment as the Moon's, although it is still unknown.
The Moon has 16.6% the gravity of Earth. Mars has roughly 30% the gravity of Earth, 33% the gravity of Earth. We do not know what the human body does with this amount of gravity. We literally have no idea. Is it more like having 1g, full gravity, or is it more like having null gravity? We actually don't know. We presume it's a spectrum, that the Moon is more like having no gravity than Mars is. Mars is more like having full gravity than the Moon is. Those are just sets of assumptions we've made, but we actually have no idea.
Temperatures on the Moon, as well, are also completely different from the Earth's, which would condition certain aspects in the functioning of the colony.
You get a temperature swing of several hundred degrees between lunar night and lunar day. The temperature difference is so great, it actually triggers seismic activity.
The frequency and duration of seismic activity on the Moon is such that it becomes a serious hazard to the integrity of a permanent base on the Moon.
There are a group of moonquakes called shallow moonquakes, and some of these reach magnitude 5 or above. And in terms of Earth, that's reasonable. But when the Moon has a seismic event, it keeps on going. It doesn't just last 30 seconds to a minute. The maximum ground motion lasts 10 minutes.
Another of the characteristics that might affect a lunar base is that, unlike the Earth, the Moon has no atmosphere to protect us from radiation and other dangers.
Not having an atmosphere on the Moon affects several things. First, again, is safety from micrometeorite impact. It comes in faster than a bullet, and you don't want to be in the way of that.
It also leaves the lunar surface exposed to half as much radiation as in interplanetary space, raising the issues of the health threat from cosmic rays and the risk of proton exposure from the solar wind. Apart from that, it's known that the presence of volatile elements on the moon, such as nitrogen and hydrogen, is extremely low. If we are not able to recover these volatile elements, they will need to be imported and recycled for life support in industrial processes. Unfortunately, this fact would serve to limit the growth of the future colony, as it would be dependent on imports. Despite all this, the proximity of the moon offers several advantages that make it the most obvious natural expansion after Earth. The duration of the journey to the moon is short. In fact, the transit time of the Apollo missions was just 3 days. In the near future, the technology will allow us to reduce it greatly. This short transit time would also be useful in case of emergencies, whether to send emergency supplies to the moon or to evacuate a human crew back to Earth.
The moon is a very interesting body. It is close to us. You can reach it in 1 week. You can go to the moon and back if you like.
The short distance causes a communication delay to Earth of less than 3 seconds. So voice and video conversations would be almost in real time and allow Earth-based teleoperation to be a viable alternative to robotics and local human operation, which is not possible on any other planet. The fact that a settler would always see the Earth as a large and much brighter object than the moon appears from Earth would mitigate the sensation of loneliness that those settlers might feel. The moon's lower gravity makes it much easier to launch rockets from the moon, as they would need much less energy than needed to escape from Earth's much higher gravity. Therefore, a lunar base could be a much better location for launching rockets to other planets, such as Mars, using locally manufactured fuel. All these advantages lead many people to see the moon as the most feasible target for a future colony off Earth. Other goals, like Mars or even the asteroids, also have ongoing projects and studies. Private companies like SpaceX and Blue Origin and public institutions like NASA are developing projects to soon colonize Mars.
There are developments underway with NASA, like the Space Launch System and the Orion capsule, to put astronauts in orbit around Mars in the 2030s.
Engineers and scientists from all over the world are working toward a new era of manned space exploration.
The moon can be a stepping stone. The moon can be something like learning also logistics. The moon has scientific value, and maybe also for tourists the moon is of interest because you can really do it in summer vacation. And therefore the moon is something also like a stepping stone to go, for instance, to Mars, but it is also an interesting destination by itself.
Its proximity and its special characteristics mean we can consider the moon a good place to settle, and it might become the starting point for unprecedented space industrial development. When it comes to colonizing the moon, one of the key points would be to decide where exactly to settle the colony. The chosen place will largely determine the functioning of the future colony. The potential locations fall into 3 broad categories: the polar regions, the equatorial regions, and the far side.
That is the main debate. Where do you go on the moon? Currently, we have mapped the entire moon and in very high detail, and we have looked at minerals and the availability of resources all over the moon. We think that The polar regions are probably more promising because there's water in those regions, readily accessible water. And water is the source of life, and if you can find water, if you have water, a lot of other things become easy to do. The polar regions of the moon also have constant sunshine. And that gives you energy, and you have water, and then you can have a permanent colony there.
Another location for a lunar base could be the lunar equatorial regions. They are likely to have higher concentrations of helium-3, rare on Earth, but much sought after for use in nuclear fusion research.
We have on Earth a very favorable situation that we have a lot of resources on Earth, all types of elements. But some of the elements are rare, and some of these elements you can find in our solar system, in asteroids or on the moon. So helium-3 is one of them mentioned, but I learned from scientists that up to now, to produce helium-3 on Earth is cheaper than to get it back from the moon.
Equatorial regions also enjoy an advantage in extra lunar traffic for launching material, as these regions coincide with the lunar orbit around Earth and nearly coincides with the equatorial plane of Earth.
Now we know that if you send a rocket ship from the Earth to the moon, there are certain trajectories called free return trajectories. That is, you don't have to put so much energy to be able to come around. Once you fly out to the moon, you go to the moon and you swing, the moon swings you back to Earth.
However, the great disadvantage of equatorial regions is that they have 2 continuous weeks of night.
That's not viable for us, because if we don't have light, we immediately have a problem with storage of power. And if you are in the dark for 2 weeks, that is very hard on a lot of systems. Engineering, tools, instruments, they all freeze.
On the other hand, the fact that the lunar far side is well shielded from Earth makes it a good location for a large radio telescope. The site would be also interesting for an array of optical telescopes because the moon also has no atmosphere.
If you go to the far side of the moon, you have the advantage, you are in the shadow of the moon concerning our radiation coming from Earth. You have a stable surface, so you can build a huge installation using moon material, and then you can have a deep view to the universe, and therefore to go on the far side on the moon with a radio telescope is for scientists already a very impressive and inspiring activity.
Once we have selected the best location for a lunar base, the next step would be to consider where and how to build to protect from radiation, meteorites, and other possible dangers.
If you're on the surface, you're exposed to solar particle radiation, which is dangerous for our physiology. The temperature extremes, that can be 300 degrees centigrade between the dark and the light. And you also have micrometeorites, which are much faster than speeding bullets, and they shower.
If we want to have astronauts over there, then we have to do something for radiation shielding. There are lava tubes on the moon. Why not using these lava tubes?
The lava tubes on the moon could be a good location for a settlement, as it would be protected from the severe hazards of the lunar surface, such as frequent meteorite impacts, cosmic radiation, and extreme temperature variations.
A lunar lava tube is an old form of flow. It starts on the surface. We see it on Hawaii. The surface solidifies, forms a crust, and the magma keeps flowing beneath that, forms an underground river. As the amount of magma wanes, the eruption dies down, that drains down and leaves a void.
They also have proven themselves as a reliable structure, having withstood the test of time for billions of years.
More importantly, we believe the thermodynamics makes us think that the interior has a steady temperature of about minus 20 degrees Celsius.
All those reasons lead us to think that the first permanent settlement on the moon could be underground. We would be protected from cosmic rays, from solar storms, extreme temperatures, and also from being hit by meteorites.
We also think that once you settle underground, you should not get the feeling that we are going to be there all the time. We would go out and do the science and tourism. The symbolism is clear. When humans started to evolve, we were cavemen. We lived in natural shelters. And it's interesting to me that you'd fly down to a new planet or to our moon, and the first home would be an astronaut caveman. But we have to learn to live outside. I think it's like growing up to be a real people. And so over time, I think we'll probably live on the surface of the moon and other planets.
A possible solution would be to construct a lunar base on the surface and cover it with lunar soil or lunar regolith, composed of rock and mineral fragments from underlying lunar bedrock broken apart by the impact of meteorites.
Well, regolith is loose material. It is often mistermed soil. Soil on this planet has organic matter in, and we know the moon does not have that. So it's loose material, loose sediment on the surface that has been formed through meteoroid impact over millennia.
Lunar regolith is composed of a unique blend of silica and iron-containing compounds that may be fused into a glass-like solid using microwave energy.
The regolith can be used as a building material because it can actually manipulate it. You can move it with the dust that gets kicked up with the lunar rover when the astronauts are up there. So you can use a backhoe, if you like, to move it around. So it's one of these features that you can pile up, you can tunnel into, you can mine it, so to speak, but you can use it as a building material. One thing we've learned is that this regolith contains very small particles of metallic iron, and that couples very well with microwaves. So you can actually melt lunar regolith in a kitchen microwave. And so you can sinter that to make it solid, at least a solid surface to cut down dust, but also to make bricks for construction.
Once we know the location, it's time to think about how to construct our first lunar base. As technology and our knowledge of the moon have advanced in the last few years, the design of lunar habitat proposals has also evolved. Concepts vary from the adaptation of landers or their used fuel tanks as habitats to different inflatable modules.
We should have what we call, in our jargon, pre-integrated structures, which are really large spacecraft with everything in it already. You touch down and you turn on the light, you have your office. That's your site office.
One of the greatest obstacles we have found to building on the surface of the moon is the dust.
Lunar dust is very, very difficult. Lunar dust is microns in diameter, made over billions of years of these micrometeorite impacts on the moon that geologists call gardening. It's called gardening, it's a geological phenomenon. And so when this powder is charged by the solar wind, it becomes electrostatically active. So when you wear a nice astronaut garment and step out on the lunar soil, the dust climbs up into your body. It goes between the seals of your gloves and it scratches your visors. And just a few minutes after any kind of work on the lunar surface, your suit is completely smudged. The thermodynamics is completely messed up. You start to have problems because you cannot see. And so dust is a problem. NASA knows this because of Apollo. So my idea was that you would build a complete lunar base in Earth orbit near the space station, because it's outside of Earth and there's no gravity. Completely assemble it and fly it as a fully pre-integrated, prefabricated structure, land it on the moon, and you have your habitat.
One of the most interesting ideas is the use of 3D printing technology to build lunar habitats. One of these 3D printing techniques is contour crafting.
There is a technique of building robotically called contour crafting. We can use raw materials from the moon, especially moon dust. We take moon dust, mix it with sulfur or some other compound to bind, and then we compress it like toothpaste and build walls. You can easily build any shape and erect structures using robotic technologies. And you can do this from planet Earth. You don't have to go to the moon to do this. So some of us believe that we can look at what is happening on the moon from Earth and build up structures to such a point that once the basic structure is built, then we can send people there to put things inside the structure.
In addition to contour crafting, another 3D printing concept is one proposed by architectural firm Foster & Partners. These 3D printers would use raw materials from lunar regolith to cover enclosed inflatable habitats for housing the human settlers, which would provide both radiation and temperature insulation. One of the greatest advantages of these techniques is that just 10% of materials for the structure mass would need to be transported, as 90% of it would be local lunar materials.
So we think by doing 3D printing activities and robotic construction technologies, introducing them, we can keep astronauts safe while work is being done. 3D printing has become an established way in a lot of robotic activities, particularly in the building industry.
Therefore, there might be several different types of colonies for the moon. Underground excavated colonies, or inside lava tubes, or on the surface. But all of them have something in common. They all need a source of energy. There are several options when it comes to a source of power for a future lunar base.
If you want to stay on Moon, either with robotics or with humans, you need, of course, energy. You need, most probably, you need electric energy. And there are different possibilities how you can get the electric energy. You can do it with nuclear, you can do it with solar energy, but the simplest is, of course, solar energy because it's free of charge and you do not have to have a big maintenance.
If we want to produce solar panels on the moon, we could extract many of the raw materials on site. The main difficulty for the use of solar power would be the long lunar night of almost 15 days. One possible solution might be to build several solar power plants so that sunlight would always reach at least one of them.
The source of energy for any permanent moon base is going to be critical. And solar is I would say, the easiest option. There's been lots of talks about nuclear fission reactors, but trying to get a nuclear fission reactor to the moon is a bit expensive and a lot of paperwork involved. But there also the fact that you don't have any clouds up on the moon, so when it's daytime, you've got guaranteed 100% energy. Solar energy is the best option.
Another possibility would be the construction of a power plant in an area of constant or near constant sunlight, such as the South or North Poles. A third option would be to use space solar panels in orbit and beam the power down as microwaves. Nuclear fission could be another possible source of energy on the Moon. With just one nuclear fission reactor, we could supply the energy requirements of a lunar base. And the handicap of the 354-hour lunar night wouldn't be a problem at all. Whether it be solar or nuclear energy that is used, how would it be stored?
Energy storage has been a problem on this planet, but right now it would have to be batteries. It'd have to be either hydrogen fuel cells or just regular batteries. And some of the missions I've looked at, which are robotic missions, we've looked at using solar and then using batteries to survive the lunar night. And batteries are heavy, so it adds mass to your mission, and therefore it adds expense to your mission. So understanding good energy storage is an area of research that really needs to be done.
At the beginning, energy would be provided by a combination of solar panels for daytime and fuel cells for nighttime. Fuel cells have operated on the space shuttle for up to 17 Earth days, so their duration would be enough for the 354 hours, almost 15 days, the length of the long lunar night. To have the supply of a source of energy is a key requirement to settle a colony. But in addition to a reliable source of energy, there is also something vital to making a lunar base feasible: a life support system.
The next step in going back to the Moon and beyond is ensuring that we make use of the resources that are available on the Moon. And that includes creating life support from the volatile deposits, hydrogen and oxygen and water.
A life support system must be able to sustain humans living in space, allowing them to survive there. It may supply water and food, as well as include monitoring atmospheric pressure, oxygen levels, waste management, and maintenance of correct body temperature.
Life support for a permanent settlement, we see in the movies that there are plants up there creating oxygen and biomass and food, and you would need that. It's been shown from the Apollo regolith that the plants can be grown in it. There's no harmful side effects from growing plant in regolith. The one thing that will be needed is organic matter, because the regolith doesn't contain any.
However, if we want to grow crops on the Moon, we will have to overcome difficulties such as extreme temperature variation on the surface, exposure to solar flares, the long lunar night of almost 15 days, and lack of insects for pollination. The fact that the Moon has no atmosphere implies that we would need sealed chambers to grow plants there, which wouldn't be a problem, as it has been proved that plants can thrive at pressures much lower than those on Earth. One of the main issues with lunar agriculture would be the long lunar night. As the use of artificial light would mean high energy consumption, other sorts of solutions are being considered, such as the use of fast-growing crops that might be started as seedlings with artificial light and be harvestable at the end of one lunar day. When it comes to settling a permanent lunar base, another fundamental need is transport. The Moon's distance from Earth is about 239,000 miles. So, one of the first obstacles that must be solved would be to develop a simple means of transport to get there. In addition, a transport system to get around on the surface of the Moon will also have to be developed. For the journey from the Earth to the Moon, conventional rockets have been used for lunar explorations to date. Another proposed concept of Earth-to-Moon transportation are space elevators. This technology would take advantage of the fact that the Moon's gravity is much lower than the Earth's.
The idea is very simple, that if you can erect a structure that is so tall that you don't have to have a rocket ship to carry stuff. Instead, carry it through a tether or an elevator to the destination.
When it comes to the transportation on the lunar surface, proposed concepts include a variety of vehicle designs, from small open rovers to large pressurized modules with lab equipment, and also a few flying or hopping vehicles. For a colony to be considered a colony and to be sustainable in the long term, it has to be nearly self-sufficient. The colonization of the moon could offer interesting business opportunities, as it could be a place for companies to develop products and services, such as a future lunar mining industry. Mining the moon's materials on-site for use both on the moon and elsewhere in the solar system where they might be needed in the future would greatly reduce costs compared to sending them from the Earth, as much less energy would be required to launch them into space.
The kind of things that we would like to see are, of course, a commercial mining infrastructure on the moon and a fuel depot associated with the Deep Space Gateway. It will only enable a trip to Mars if you can store fuel and resources in the vicinity of the Deep Space Gateway.
As the mining business in space develops during this century and human beings become a multiplanetary species, large amounts of matter will need to be launched to several locations in the solar system. Therefore, the moon could come into an interesting option to reduce the costs of interplanetary cargo transport.
If you can then refuel life support in rockets going to Mars and beyond, as well as fuel using lunar resources, you've then reduced the mass you need to lift off this planet. So it becomes an enabling asset not only for lunar exploration, but solar system exploration.
In the near future, the moon will become a key platform providing raw materials to space-based construction facilities. Construction in space, as well as manufacturing and other industrial processes, will increase considerably as zero gravity will make these kinds of processes much easier and safer.
It will make sense to move manufacturing off the surface of the Earth. And as Jeff Bezos says, all the heavy manufacturing will be done in space, and the surface of the Earth will be zoned for light industrial and habitation.
To reduce the cost of transport, the moon could store propellants produced from lunar water at one or several depots between the Earth and the moon to resupply rockets or satellites in Earth orbit. We know that water is a key resource as it can be used to produce rocket propellant and also to produce oxygen, absolutely necessary for colonization and life support. After having analyzed all the key points to be considered when building a future lunar colony, such as the location of the colony, the energy source, transportation, and the economic development of that settlement, we can undoubtedly consider that the building of a lunar base would be one of the greatest technological challenges that humankind has ever faced. Despite the huge difficulty that a lunar base brings with it, there are already some proposed projects in the near future by several public institutions and private companies. The first one was the Lunar Reconnaissance Orbiter, a NASA robotic probe launched in June 2009, and which is currently in orbit around the moon. It has scanned and mapped the lunar surface in very great detail. It has identified safe landing locations, searched for potential resources, analyzed the environmental radiation, and tested new technologies. While the U.S. currently has no firm plans to return to the moon, the European Space Agency, Russia, and China have all expressed interest in building a base there. In fact, the ESA, the European Space Agency, has designed an ambitious plan to settle on the moon in the near future. The Moon Village. It was announced by ESA Director General Jan Warmer in April 2015 during the Space Symposium in Colorado Springs, USA.
Moon Village is an open concept with free and open access for each and everyone, be it industry, be it the public sector. It is open for robotic activities, it's open for human activities.
The Moon Village is intended not only for scientific and technological activities, but also for activities based on exploiting resources or even tourism.
This is the idea of the Moon Village concept. And I can tell you that now already a lot of different entities worldwide, private and public entities, are interested and bringing different parts, very different parts into this idea. And I'm very happy that now also some entities like Blue Origin, Jeff Bezos, but also Elon Musk are announcing that they are interested to go there.
It is clear that in the future, humans will take part in crewed flights farther into the solar system. So the Moon Village could also act as the perfect springboard and testing ground with that objective in mind.
I believe that the Moon Village is already in its development phase, and it's only a question of a month or let's say 1 or 2 years that we really see hardware on the Moon belonging to the Moon Village.
The Moon Village would be a first step in the future exploration of Mars, as it would also act as a pit stop. At the beginning, there would be just robots, rovers, and huge 3D printers that should build the modules and habitat where the first astronauts would live in. In addition to the Moon Village, there are other projects led by other space agencies that intend to go back to the Moon in the near future. The China National Space Administration has commenced the Chang program for exploring the Moon to investigate the prospect of lunar mining, specifically for mining isotope helium-3 for use as an energy source on Earth. The Russian Federal Space Agency Roscosmos has planned a fully robotic lunar base called Lunar Polygon. The project is planned for the second half of the 2020s. Scientists hope that in the near future, we will witness the creation of the first lunar base for human beings. What may become a reality much sooner is tourism on the Moon. Some space tourism startup companies are planning to offer tours on or around the Moon in the near future.
We do believe that the first really big industry in space is going to be space adventure travel. And so people on vacation will be traveling from place to place in space, and we'll be providing the propellant so they can get to the space hotel and back.
Some individual companies as SpaceX, Virgin Galactic, or Space Adventures estimate that lunar tourism will be a reality sometime between 2020 and 2043. The company Space Adventures has announced plans to take 2 tourists to within 100 kilometers of the lunar surface using a Soyuz spacecraft piloted by a professional cosmonaut. In these future luxury tourist trips, exotic attractions might include the view of the far side of the Moon, which can't be seen from Earth, or the view of the Earth rising and setting against the lunar horizon. The interest of several private companies in space exploration is already a fact. The private sector is already working to begin a new era of space exploration.
We should return to the Moon as a stepping stone to Mars, but that it should be done commercially with public-private partnerships. We do not need a large government program like Apollo that focuses simply on having human beings walking around on the Moon, but instead we need to focus on developing lunar resources to enable eventual trips to Mars.
This collaboration between private companies and public institutions will soon produce great results in the adventure of the colonization of the Moon, to later expand to Mars, the asteroids, and other places.
That brings up the next major development in human history, and that is, for the first time, we have extremely wealthy technological entrepreneurs that want to move the needle of history. This hasn't been the case since the late 19th century and early 20th century that led to the massive industrialization and improvement in wealth all around the world in the 20th century.
This might be the first step of a new era, an era in which the Earth would no longer be our only home.